Good afternoon. I'm Steve Moretti. This is Russ Craxford. We've got a few questions to ask one another and talk to today. So we're going to start with the first one. Tell us about your background, Russ.
Yeah, so I've been in engineering about sort of 15 years in various guises, mainly around software testing, partly in delivery management. I've worked in various sort of fields from the government currently into sort of charity sector, insurance, banks. I've done the around the houses sort of thing, a little bit of consultancy in the mix, various different things. Passionate about kind of quality engineering, how we make things better and keep customers at the heart of what we do, because ultimately it's delivering for them. That's important. So it's kind of a bit of a hobby of mine as well. Events, conferences, communities, get involved in all that sort of world to try and help promote good cultures and good ways of doing things.
What got started? You started in all the quality testing side of things.
Accidents. Usually it was a big accident, really. So I was working in a call center and volunteered to write a training manual because I didn't want to be on the phones. And that training manual grew into telling them that you couldn't actually write the training manual because it didn't work.
Right.
And then I started finding bugs and exploring what to do with it, and that morphed into a kind of quality testing role.
Awesome.
So I ended up setting up a test function for a business from scratch. So that's how I got into it, from accidents.
It's always when you try and do these things that you find out the problems, trying to write them down that you...
Yeah, it's interesting because like a lot of testers you'll hear come from the background of they worked in a business or does things. It's shifted a lot recently towards more engineering. So people are coming from engineering backgrounds, coming from universities, coming from boot camps and things like that, as more of the skills have grown more technical in depth. So it's the evolution of how people get into these roles is changed over time. You still get a lot from the business, come through routes like I did, putting a hand up, volunteering for UAT, user acceptance testing, those sorts of routes. It has evolved over time. What's your background, Steve?
So I've been in software engineering for since university days, and I started with web application development in the early 90s, when nobody really knew how to build websites or web applications.
Did they still?
Well, it's a question sometimes. In the late 90s, that's when I started properly building web applications with new media companies, doing work for the BBC, and about 9 years ago, I started working for DWP, just as DWP was starting to insource all of its development work. I joined primarily to try and help with doing that. There was a few little bits and pieces of teams, and we've grown to the point now where we've got 1,800 engineers in DWP, and a lot of it is insourced and not so much outsourced. I've helped. When I first started, we had about 10 or 15 people across Blackpool, Leeds and Newcastle, and we took them from doing VBA to doing Node.js and Java, and teaching them how to do agile development, Scrum and Kanban, those kinds of things. And that, I've been doing that in various forms up to this point today.
Yeah, I would say a lot of it is how teams interact, isn't it? Software is kind of what's the right way of saying it? Is the outcome of communication of the teams and the structures of the organizations. There's a lot of it's the technical skills.
Yeah.
But without the communication, without the collaboration, without the breaking of barriers between the customer to the designer, with everyone else in between, like our roles, it doesn't work successfully. And actually the best success comes from that collaboration. Remote working has become much easier now with the better tools to do it. And obviously we, DWP Digital, we have a lot of remote working. Yep. We have to collaborate in offices, and we have some great spaces.
Yep.
But we also do quite a lot of work remotely. And tools like Teams and Slack and all the video calls and conferencing we do helps dramatically get that sort of team working. And I know, like, we are actually located in the same office technically, but a lot of our colleagues are actually in different places around the country.
Yeah.
So it helps us get effective work by having these tools.
I think that might actually lead us on to our next question. So the next question is, what role does engineering play enabling DWP to provide its services?
Oof, wow, profound. Yeah, so engineering is kind of at the root of a lot of things that DWP do. So from the machines that our agents will use to make calls, receive calls, make calls, from the emails that we get, from the websites that we actually have information on, from the business processes that are run by them, from the debt collection to the collaboration, to the video calls with a work coach and all the rest of it.
Yeah.
It's all based on some sort of solution now, which is engineered in some way, shape or form.
Yeah.
So a lot of our teams are building these. Sometimes it's collaboration with third parties. Sometimes we have a bit of a SaaS, software as a service, built in. But our engineering teams that we kind of work with are often the ones working with architects, with designers, with business users to actually design these services, influence how they're built, deploy them services, refine them, get feedback, fix the problems, because we'll be blunt, all software has issues. And we obviously have to make sure it's the least as possible, impactful, the least as possible. But it's all about maintaining these. And obviously in engineering, certainly my roles, my teams and the areas I work with, it's all about trying to advocate for quality, how we improve things, how we make that quality continuously better, how we learn from mistakes, how we make sure that we don't repeat them, and those sorts of things. And we feed back into the wider teams to do that. And I think you know, your role in your areas have something similar, don't they?
Yeah, so site reliability and DevOps engineers are there to improve processes and make sure that things are efficient, robust, reliable, through automation, monitoring and observing our services. So making sure that things are repeatable, and we can
kind of take that for granted sometimes, that repeatability-ness and the automation of it. I know that for some of the DevOps work that we do, it makes other work so much more easy. Because we're not having to spend time and toil working on recreating environments or doing things. We can repeat them. We know that when it goes from one place to another, it'll work the same because there's no human error involved in them. It's all processed. It's all engineered so that it's repeatable. And the amount of effort that saves is quite extraordinary from when I started out in engineering worlds. The amount of manual configuration, the limitations of environments, to what we have now, where we can be quite keen, quite easy to understand what we're putting in each environment, and repeat it, which reduces just the little errors that cause catastrophic problems. So don't get me wrong, we're not error-free, as I mentioned, but we do reduce the errors by actually fixing it where we first find it, and then it's obviously automated, fixed all the way through the pipeline.
The advantage of automating some of these things means that we've those things that we can easily repeat, we are repeating, and you can just keep doing it over and over, and it means that people can actually concentrate on the more interesting problems, the harder to solve problems, rather than on the things that actually is just a point and click or a copy and paste.
It means we can add more value to the citizens, in effect. It means we can add more value to our colleagues, help them expedite things in it. And it works across every activity of engineering, really. You know, we talk about DevOps, we talk about SRE, we talk about testing, development. It's the whole area. The more that we can actually streamline, more efficient, the more value for money we provide, which ultimately means a better service to the people that we represent, because we're paid for by taxpayers and provide a service to the community. It's quite an passionate thing.
Should we see what the next question is?
Go on, let's go on. I'll do the damage.
Go on then.
Okay, what's been your favourite experience then so far working at DWP?
Actually, one of my favourite experiences has probably been one of my earlier experiences at DWP, where I got an email that started out with, "Don't panic, Sir Robert has a request." Now, Sir Robert, if you didn't know, it was the permanent secretary for DWP at the time.
Okay.
He basically, the email was, we need, in a time when digital wasn't that big, when engineering colleagues were quite limited, they needed a few good people to try and put together a service quite quickly. And I ended up working with architects, testers, software engineers, delivery managers, security people, to, within 12 weeks, create a minimum viable product to enable all of the DWP colleagues to put their working patterns in to help with the employee deal process that was being put in place. So that was 100,000 people that got to use that service within 12 weeks. So that was good fun.
Yeah. So I have to admit, I don't think I've actually built anything in DWP personally, which is a slightly disappointing thing for me. But I think my favorite experience was probably when we were on stage. We did a sort of internal conference event and getting them in front of a community and talking about DevOps and the pillars of DevOps and actually what's behind it, what's driving it versus some of the activities that often gets assumed to be the actual challenge. So getting up and talking about that, seeing the community, probably getting some positive feedback, but actually being able to engage with the people who are doing the work a bit more physically with them, supporting them, answering questions, asking questions, I think was probably my favorite thing, because you could see the impact and some of the people going, oh yeah, that's what it's about. Remember that, I forgot about that. And just trying to refresh their minds, because we all get sort of this tunnel vision to an activity, a goal or a purpose. But actually being able to expand people's eyes and kind of to look at the broader picture was probably a nice win to have, and just reminded people of the purpose and so on. Yeah,
I talk quite a lot, but in meetings, but I'm not the greatest public speaker, but it is good to be able to get up in front of people and help answer their questions. So yeah,
to be visible as leaders, I think is really important. But yeah, different forums and different ways of doing it.
Yeah.
So how many engineering disciplines are there across DWP Digital, do you think, then, Stephen?
Engineering disciplines. Depends what you call a discipline, but
yeah.
In engineering, if you talk about job families, we've got, well, obviously, we've talked about this a little bit previously, but we've got technical leadership, site reliability engineers, and DevOps, who I look after. Yourself, you look after...
I'd call it testing as a discipline. There's two different roles. There's more engineers and then there's more sort of hands-on testers, but ultimately it's the discipline of testing. We've got sort of software development, which again you could break up into kind of front-end development, back-end, application development, and those sort of spaces. You theoretically have sort of data engineers. They exist in the engineering area, but not in the practice.
Yeah, and then we do have quite a lot of infrastructure engineers, and they've got a variety of different roles. Some of those cross over with our DevOps and site reliability engineers, but equally there are a lot of them that work to deliver the things that keep us running. So the cabling that's in this building, the networking, the security infrastructure, all those kinds of things that keep us wired together.
Yeah, there's a lot of different types of infrastructure, just because there is so much different technical infrastructure around.
Yeah.
So yeah, there's quite a few disciplines, and there's something for everyone almost to a degree.
There is,
because you need different types of personalities, and I'm a big fan of diversity of thought. So actually having different people with different backgrounds, from even technical and non-technical, to come together can actually help make kind of a better practice as a whole.
Yeah,
because actually brings different perspectives, things. So it's quite good that we have these roles, and we get them together as well at times to talk, to share their problems and successes.
Yeah, I think I would like it if more of our engineers got together and talked to one another about more things. I think some of them would probably find that they've got more commonality than they thought, as well as being able to help people solve problems in different ways.
Yeah, it's that one of the very important things about the different disciplines. The one thing they all have in common is problem solving. They're all here to solve problems. That the service that they're providing is a problem solving. maybe technical in how they implement it, but ultimately they're here to try and solve a need or a purpose.
Yeah.
And they're doing it in the background usually in order to try and help achieve that outcome. But it is amazing how all the different disciplines can either work slightly independently or together to get a better outcome. Yep. But it does depend on the discipline.
Funnily enough, our last question is what skills do you think great engineers need?
Well, problem solving then, as a starter for 10. I think we touched on a couple of them already, really. So communication, I think we've mentioned, and collaboration. Problem solving are two of the kind of cornerstones for most of these things. I like to think from testers, it's about thinking, system thinking, the what if, the broader aspect.
Yep.
You know, not just like my line of code, but how is this line of code going to work in conjunction with everything else, or with the infrastructure, or the end solution? What the value will it bring? So it's that big picture thinking, I think is really useful.
Yep.
What else? What other skills can you think of?
I think, well, we talked about problem solving, but problem solving it also goes into thinking about innovation and understanding what's coming next.
True.
So, you know, it really, to some extent, it depends on your level of experience and what you've been doing, but every engineer, regardless of their role, probably should make sure that they understand what's coming next, how they can use those to improve their life, and how they can improve the processes around them and the things that they do.
I guess it's that skill of, reviewing what you're doing almost, and refining it, and sort of self-reflection as well as kind of like technology reflection, so that you keep an eye on what's the things there. So we haven't talked about them, but in a lot of our roles, there's engineering skills that are particularly needed as well. So the ability to use code in some form, source control, and all these sorts of technical things benefit in many things, especially now as infrastructure as code and test automation. There is quite a commonality in the engineering space that the ability to adapt to technologies. So, you know, when we started out, I think there were certain tools that existed that don't exist even now. And the tools change, the technologies change. You know, predominantly we're writing in Java and Node.js right now. I don't remember exactly, but 10 years ago, Node.js wasn't around. So all these languages change. Python's quite popular in some of our areas for data science, data engineering. So the technologies and tools we use change. So adaptability is, oddly enough, one of the key skills, because what you do today, like we've built COBOL systems in the past. We maintain them now, but we build things in different technologies. And the one thing I can guarantee with certainty is technology is going to change. It's changed already in the last few years. You know, the different technology for testing has gone differently in 2 years. So it changes everywhere. So your ability to deal with change is probably quite a strong skill. And to adapt your skills. There's a lot of skills we want for engineers, isn't there, really? But it's learning and all sorts of things like that.
I mean, if you think about it, technology has changed quite a lot. So some of the historically hardware-related things are now starting to become software-driven as well. So networking is software-driven and not just
not just plugging things
into boxes. So it, you know, problem solving, adaptability, communication, innovation.
Open-mindedness. I guess.
Open-mindedness. I think we have a set of engineering principles.
We do.
That talk about things being data-driven. About things being reusable. About things being sustainable.
Environmentally and so on. And pace-wise as well.
And you know, you've got to have that forethought to think about how you're going to make sure that the thing that you're going to build is going to be reusable, sustainable.
How are we going to maintain it as well? I think some of the classic ones that often get forgotten, get out of the door, then just walk away, whereas actually, no, you've got to maintain a service, or you've got to end of life a service. So you've got to kind of think about that future-proofing, how you're going to maintain it, how you're going to test it, how you're going to add to it, extend it, end of life it. All these things come part of parcel of it these days. It's quite a broad spectrum, isn't it? Do you think there's any benefits of having sort of software standards or anything like that?
Software standards? Well, standards in general.
Well, yes.
having standards means that actually we can be more consistent. That actually, when we get new people coming in, they've got a starting place, and it doesn't matter who they talk to, they'll get the same answer. Back to the consistency point.
Yeah.
This will make you happy. Standards means we'll improve quality.
It means we should learn from the lessons more consistently across the board, yeah. Rather than learn one little area and not another area, yeah.
Yep. What else for standards? I think it allows us to be more secure because we've learned and we're being more consistent. It realistically, we keep saying the word consistency for standards. It does just mean that we are that little bit more consistent about how we approach and how we deliver things.
It can help speed up. It can also hinder speeding up, like most things in life, depending how you do things.
Yeah.
But if you have something that people can use as a basis, a starting point, it allows you to get started faster. An example would be like a standard way of doing a new service. If you can get a boilerplate code or boilerplate examplers, that can theoretically do it. If you've got coding standards, again, when you move people between teams, there's a consistency of expectation. The quality and the maintainability is at a similar bar. So again, it allows people to kind of be more effective in many ways. But like everything, you can standardize everything too much, then you've got robots.
Yep.
We're thought workers. We like to think of us as thought workers.
Yep.
I want to have some freedom of expression, freedom of experimentation, innovation.
Yep.
So it's all about those balances. And I do think that the size that we are, mentioned about 1,800 engineers,
yep,
we've got to leverage our size to our advantage. And that's sharing information, cascading things.
Yeah.
And, as engineers that come into DWP, one of the things we're looking for is people to share, to collaborate, to talk about things, to promote positive outcomes, to also talk about what went wrong. Like, we try and talk about blameless culture. We want to learn from our mistakes. It's not to point a finger. It's actually so that, if something does go wrong, the classic ones I see in testing are boundaries. People forget what a working day is versus a day and things like that, or some months have 31 days and some 28. Those little things, just to talk about them, makes other people more aware of them.
Yeah.
And standards can actually help by giving you a standard, we call it in testing heuristic, of things to consider when you're doing things around dates. It can be little things like that, or it can be, these are the tools you use. And it all varies to a degree. But the more that we can collaborate, the more that we can share and build common ways, common standards, it helps us all become a little bit faster. The shortcuts.
Yep.
Again, they go to this idea of a heuristic. So I think they are a fantastic idea. Like everything else, it depends how far you push them. I've worked in organizations where there's only one way, you might as well just use a robot to do my work.
So we talk about all these standards that we want people to adhere to, but where are they coming from?
That's a good question. So I think certainly you are probably in the similar ilk to me, which is we believe in community.
Yeah.
We believe that actually the best people are the people actually doing it, working together collaboratively. They won't always agree. And this is a little bit where we come in as kind of heads of role and leaders to kind of help shape and nurture and to round off the edges, so to speak, but to help kind of promote good practice comes from the community itself.
Yep.
By having forums, conference I mentioned earlier and things like that, by actually getting them to publicize things, to put it into a findable, visible place so that actually discussions can happen. But also not, like I've seen standards where they were written 5 years ago, you never touch them, so painful to change them, they just die.
Yep.
So it's about trying to make them so that they're livable, amendable, flexible. These are all lovely words, hard to do. So we kind of have like a community kind of where you put an idea forward and open up to the community for feedback. If they agree, disagree, we have those discussions and then we ratify it, but we try and keep that into kind of a time box.
Yep.
So that actually, whether it's agreed or not, there's at least rapid process. And rapid's debatable, but it's definitely a process of feedback loops.
Yep.
So that we can actually go, well, actually, I disagree with that. Great. What should it be? So actually, we promote this idea of conversation, debate, and consensus. Like, perfect is the enemy of good enough.
Yeah.
So it's all about getting something out there, and those timelines drive that. What's better? What will improve it? What will help us get that next hurdle? And I think standards built like that generally are better. They're not going to please everyone, but it helps have this idea of a common way of working.
Yep.
Does mean they're evolving, so people have to be on top of them a little bit because they're evolutionary. But I do think it helps actually build a culture, and I think that's ultimately what me and you are partly responsible for.
Yep.
Building a culture that enables people and helps people grow, helps understand what value they can have, and helps them have an impact across such a broad organisation.
Yeah. The benefits of having community-driven standards and people having that conversation in those standards is that actually when somebody reads it and they don't understand it, we can rephrase it so that they do understand it and they become well understood and easy to understand.
Yeah, we end up educating each other, which is fantastic. Anyone who's worked in government before will understand that we use acronyms more than most places. Anyone who's worked in IT probably know IT uses acronyms galore. So, the ability to be able to question things and not be criticised for questioning things, asking for ideas, being open to the fact that everyone's on a different journey. So different parts of our organisation do agile better than others. Different parts do testing better than others. That's fine, because actually there's different ages of applications, different maturities, different history to get to where we are.
Yep.
We accept that fact. The key is moving forward. How do we get better? And, perfection is the enemy of good enough. So it's about what will help that team get better. Sometimes it isn't perfection. Sometimes it's iterative.
Yep.
And I think that's a lot of our thing. So we might write a standard of this is perfect world. But actually, how can you get closer? That's normally the ask.
Yep.
Not how do you get to the kind of top of the mountain? Well, how do you get over the next reach? Yep. I think that's often what we try and look for. And obviously, new projects, we want you to strive for the top of the mountain. Existing things, how do we get closer? That's kind of our goal.
Yep.
If our engineers work towards those purposes, we end up with a better solution. We end up with better. And I think that's sort of the thing that drives us all is, perfect, wonderful, love that. Perfect across hundreds and hundreds of teams, 2,000 people roughly, isn't what you're going to get. How do we just make it better? How do we help the people that want to improve the world?
Absolutely.
And it's a great point to end.
Thank you very much.